Welcome to springlib.
We have a data set here and the frequency histogram representing it. In part A, which of these measures of central tendency take more than one value? Okay, so I'm going to start by defining measures of central tendency. We have three of them here: the mean, the median, the mode. Now, the mean is what you get if you take each value, you add them all up, you divide by the total. So it cannot take more than one value. It's something you calculate from your dataset. You just get this single value. So we can ignore that one. The median, where you put your data in order from smallest to largest, and you're looking for the value right in the middle. Half of the values are below it, half above it. Again, it's just going to be a particular value. You can't have more than one. If you have an even number of pieces of data, say I have 4 pieces of data, my midpoint is found at n plus 1 over 2th piece, so it would be 2.5. Maybe you have 2 and 3, and you're asking, okay, maybe the median is both of them. No, you just go halfway in between. So you never get more than one median. If you end up needing something that's a 0.5, you just go halfway. The mode is the most frequent value. Now this, it is possible to have more than one. If you have multiple values that have the maximum frequency, but there's multiple of them and they have the same frequency, you have multiple modes. You can also have no mode at all if everything has the same frequency. So what do we have here? So going through the dataset, I see we have 2 17s, that's my first candidate for mode, 2 33s, that's another candidate, 2 49s, 2 57s, and okay, so there's a lot of values that have 2, but nothing more than that. So this is multimodal data. The mode does take multiple values here. B, the measurement 87 is the largest measurement, and we replace it by 98. Which of these would be affected? First of all, the mode wouldn't, because 87 wasn't one of the modes, so it's not affected here. The median also is not affected. So there's 25 values, that means n plus 1 over 2 is the 13th. We're just looking at the middle value. The middle value doesn't care if you've changed the maximum one. So that's not changed either. But the mean has been affected. Every value affects the mean because you're adding up all of the values and dividing by the total. Okay, so now we have the original datasets and we take away the smallest measurement. So we remove that 14. So the mean is going to be affected. Again, every value affects the mean. Taking one away is most likely going to change it, especially if you're taking away the smallest one. What about the others? So for the median, we'd better find out what the median was and is now. So previously it was the 13th value in ascending order. So previously 14 was the first value, 17 was the second and third, 23 was the fourth. The median was 52. Now we're changing things. We've removed 14. Now there are only 24 values and we need the 12.5th. So I'm going to find the 12th and the 13th and we're going to go halfway between them to get the median. So remove 14. Okay, and the 12th is now 52. It's gone down 1. And the 13th is 53, giving us a new median of 52.5. So the median has changed as well. And again, the mode hasn't changed because 14 was not previously one of the modes.